Hey everyone, welcome back. So today we're going to be solving Leetcode 465. This is a medium question, and I'll be solving it in Java, but the concept remains the same across all the languages. So yeah, let's get started. The problem is, it's actually a bit tricky, but once you know the approach, it's gets pretty simple, and I'll be solving the problem with you. I've not submitted any solutions, and I'll be doing it, you know, uh, with you guys, right? So let's get started. The problem states that you're given an array of nums, right? In the array of nums, you're supposed to find a pattern, okay? And what is that pattern? It's called as 3 to 1, 1 to 1 3 2 pattern, right? What is this pattern, right? When you look at it, visually, what is 132, right? It is nothing but pattern where your 3, that is the middle element, is greater than my first element and also greater than the last element, right? So it is given to you that given an array, you have to find if the 3 to 1 pattern exists in my input array, right? And according to the question, what is the 3 to 1 pattern? It is when your I is greater than I is less than j and j is less than k, right? This is nothing but your index. So ideally your j should be greater than your I and your k should be greater than your j, right? And also greater than I, obviously it will be because it's greater than j, right? So for this particular index, this is the pattern that you need to figure out, right? So nums of I, okay, is less than nums of k, right? Less than nums of j. Or another way to write this would be nums of I is less than nums of j, it's greater than nums of k, right? Because if you see over here, your j is greater than your k and your I, right? Similarly, your j is greater than your k and also greater than your I. Perfect, right? So we need to figure out this pattern, if this pattern exists in our input array or not, right? So let's look at few examples. Let's pick up this example, 3 1 4 2, right? So if you see in this example, that is 3 1 4 and 2, right? What do we see? Do we see a pattern of 1 2 3 1 3 2? Right? We do, right? If you see over here, this is my I, right? This is my I, right? This is my j, right? And this is my k, right? So if you see over here, it follows this condition where I is less than j less than k, right? And it also follows this condition, right? Because my k is greater than I, okay, and my j is greater than k, right? So it follows this particular condition as well. So I have a 1 3 2 pattern in my array, so I can return true over here, right? I can return true, right? So this is ideally what we'll have to find out. Okay, so now let's see how we can do it in a brute force way. Then let's get into an optimal approach, right? So given this is your input array, ideally what do I need? I need 3 values, that is nums of I, nums of j, and then nums of k, which needs to follow this particular condition, right? Right? So now what I can do is I can find out k value, right? I'm choosing k value in this particular input array. I'm going to find out this k value, and for every k value I'm going to check, is there a value I and j before k which exist in such a way that my nums of k is greater than my nums of j. Nums of k is greater than nums of I, right? Also my nums of k is less than nums of j, right? This is what I need to find out, right? If my nums of k is less than nums of j and my nums of k is greater than nums of I, what can I say about I and j? What relation can I form with I and j? Of course, nums of I, with this I can say that nums of I would be less than nums of j, right? Because your nums of k is less than nums of j, right? And also it is greater than nums of I, right? So I can say that nums of I would be less than nums of j. Perfect. So for every value of k, I need to figure out, is there a value before, is there a value like in this array, is there a value before, sorry, is there a value before where I can find out these two conditions, right? These two will be my conditions, right? Now let's see. So taking the same example again, I have 3, 1, 4 and 2, right? Let me go through the array, right? So I can come here, this will be written in because there are no two values before it, so forget that. Here also there are no two values, I'll go here, right? At 4, is there a value which is greater than 4? No value is greater than 4, right? Let me eliminate it actually. There's no value greater than 4, right? Perfect. So this is also actually, let me not eliminate it because it could be in other answers, right? So what I'm trying to say is, this is not your answer, this is not your answer, because there are no two elements before it or two elements before this, right? Now coming to 4, there are two elements before this. Is there any element which is greater than 4, right? To get this condition, to get this condition, that is, get a condition where nums of j, right, is less than nums of is greater than nums of k, right? If you see over here, at 4 there are no elements greater than 4, right? So this also cannot be my answer. Now I'll go here. Okay, for 2, I'm checking if there any element greater than 2, right? Yes, the nearest element greater than 2 is 4, right? So I can say that maybe this can be my k and this can be my j. Why? Because I found a value which is greater than 2, right? Okay. Now what I'll do is, I'll fix my k over here, right, and I'll fix my j over here, and I'll iterate from this point. Right? Why? Because your I is less than j less than k, right? This is your condition, right? I'll iterate from this point. Now okay, now I need to find out, is there any value less than 2, right? That is my first condition. Is there any value less than 2, right? So now what will I do? When I come here, okay, I see that 1 is less than 2, right? There can be a lot of combinations, but since we just need to return true or false, we can just figure out if there's one particular combination, and if it exists we can return true, right? So I've come to 1. Okay, I see that 1 is greater than 1 is less than 2. Perfect. Have I found my answer? Yes, I have, right? 1 4 2 follows 1 1 3 2 pattern. So here I can return 2. Perfect. Okay. Now that we've seen the brute force solution, let's see if it actually work out or not. Right. Look at the constraint that's given to you. N is going to 2 into 10 power 5. Right. 2 into 10 power 5 is the maximum value of n. Right. Now can we apply brute force? What is the time complexity of brute force? Right. So taking the same example again, if you have 3, 1, 4 and 2, and you're fixing your k at here, okay, you'll have another loop running through the entire array, left side of the entire array, trying to check for element greater than 2. Okay, so you'll have first for loop will go from here to whatever that is, n, right? You'll have one for loop. The second for loop would ideally go from I minus 1 to I minus 1 to I minus 1 to 0, right? That will be a second for loop. Now let's say that you've set your j over here. Perfect. Now you'll have a third for loop which runs from this point to 0, right? So your j, I will be this thing, and your j will be, this will be your j, right? It will be I minus 1. So you'll have another for loop which will run from I, like I'll call it k, which will run from j minus 1 to 0, right? So you'll have another for loop running. right? So you'll have to go through the entire array, check if there exists a number which is less than k, right? In worst case scenario, if the size of the array is increasing, like 1 2 3 4, you're gonna come here, you're gonna see any elements to the left, no. You're gonna come here, no element greater, no element greater, and then no element greater, right? Like in this case you'll be going through the entire array, right? This case we did not, because we found the answer immediately, but we'll be going through the entire array, right? So the complexity of this approach would ideally return O of NQ, right? This would be our time complexity. Okay, now with this time complexity, will our code run? No, right? Because with 10 power 5, 10 power 5 into 3 will be 10 power 15. It's a very, very, very huge number. So our answer will throw TLE for sure, right? Okay. So now there is a need to find a better approach, right? How can we find a better approach? Let's think about it. Okay. Let's take the same example. 3 1 4, right? So 3 1 4 and 2. Okay, that's 0 1 2 3, right? So now tell me something. Let me write the condition again. Your array of k should be greater than array of I, perfect, and your array of k should be less than array of j. This falls under condition I less than j less than k. Perfect. This is my this is nothing but my conditions that I have to follow, right? This is my input array. Okay, let's make some observations, right? How can we optimize this? Can I say that to optimize this, what I can use, such that I don't have to compute, like, when I was over here, I was ideally going through the entire array, right, to figure out the value greater than 4, right? Now tell me something. If I already have a data structure which is holding the value greater than 4, or when I come to 2, right, if I already have a data structure which is holding the value greater than 2, I don't have to iterate, right? I can retrieve it in O1 operation, right? So I don't have to go through the entire array. Perfect. Now that is one case, right? Now let's say that for 2 I have a data structure. I don't know what data structure it is. Let me put a question mark to it. Let me put a question mark. Let's not think about what data structure we're going to use. Let's just say that there is a data structure which is holding the maximum value at any point, right? Now for at 2, okay, the maximum value this data structure is holding is 4, right? Now, okay, I found this thing. Now I need another variable or another data structure, okay, which is ideally holding my, not a data structure, this can be a variable also, right? I can have a simple variable which is holding my minimum value till 2. That is minimum value till before 2, right? So I need some data structure which is holding my minimum value before 2, right? So that is very simple, right? I can just take a minimum value, when I'm iterating through this array, like, ideally when I'm iterating through this array in this way, right, I can store my minimum value, right? Now 3 is my minimum initially, this is my minimum, 3 is my minimum. Then what would happen is 1 would become my minimum, 3 would be my minimum for elements before 3. For elements before 1, 3 would still be my minimum. For elements before 4, what would be my minimum? 1 would be my minimum, right? And for elements 2, 1 would still be my minimum, right? 1 would still be my minimum. Perfect. Now 1 would still be my minimum, right? Now I can have a variable which will hold the minimum value. Perfect. If I have these two, right, if I have these two set up, okay, whenever I'm iterating through the array, right? Whenever I'm iterating through the array, I can check if the element from this particular data structure is greater than 2, greater than my current element. Okay, if it is greater than my current element, perfect. If it is greater than my current element, I can also check if this current element is greater than my minimum value, right? So if this particular data structure is having an element greater than 2, right, and this minimum value is having an element less than 2, can I say that I found my answer? I can. Why? Because this data structure is holding nothing but my j, right? And this variable is holding nothing but my I, right? And this value is nothing but my k, right? So I can say that if my current value is less than is less than it's less than, if my current value is less than what is in my data structure, that is my j value, right? And if it's also I'll mark it as array of j, right? That is whatever is stored in this data structure, right? And if it's greater than my minimum value, I can say that I have found my answer. I'll just return 2, right? I'm going to return 2. Perfect. Now, what data structure can we use? I'm going to be using stack over here because stack is something that where you can pop out and then you can store at a given point. You can store the element, the maximum element before the current element, right? And then I can have a minimum value where you can store the minimum element before the current element. Ideally, you can have a stack for this as well, right? But you don't need to. You can just have a variable min value, and then you can append it to the element of the stack. How will append it? We can use anything. I'm going to be using a pair. You can use a pair and append the maximum element and the minimum value before the current element, right? Perfect. Now let's take an example and let's see how this works. Okay, let me actually take another example, 350. Right? Let me index it. Perfect. Now I'm gonna have a stack, right? Which will look something like this. This is my stack, and this will contain minimum, ideally max value, right? This will contain my min value. What are these? These are max value and min value before my current value, right? Right? Before my current value, right? Now, if you take 3, right? What is my max value before it? Nothing, right? So I'll store it as 3 only. My min value also will be 3. Perfect, right? Now I'll go to 5, right? I'll go to 5. So our current minimum is initially 3. It's the same thing over here, right? Now we're going to 5, right? What is our stack holding? What is the max value holding? It's holding it's holding the greatest element towards the left, right? So is 3 the greatest element? No, 3 is not the greatest element, right? So what I can do is I will remove this, right? I'll remove this out of my stack, as in I'll pop it out of my stack, right? Should I pop it now or should I keep it? Let's think about it. Right. I'll have to pop it out of my stack, right? Because what is our stack holding? What is our max value holding? It is holding the maximum value before the current element. So my current element is over here now, right? So it is holding the max value before the current element, which is 3 ideally, right? But if you see over here, 3 is less than 5, right? So I'll remove 3, right? I'll put in 5. Can 3 be my maximum element for the further element? No, because I've encountered 5, right? I'll keep 5, and my minimum that I've encountered is still be 3, right? Now I push my current element 0. Okay, I got an element less than 5. Okay, perfect. I got an element less than 5. Now I found the top of my stack is containing an element less than 5, right? So ideally this is my k, this is my j, and this is my I, right? So I need to see if my top of the element is greater than the current element. Yes, top of my stack is greater than the current element. Perfect. What about the second condition? Is my k greater than my I? No, it's not greater, right? Because this is 0, this is 3. Okay. Now what do we have to do? Okay. Now what we'll do is we can't remove 5 because it is the greatest. It is the greatest element till now, right? But 0 can be a greater element for my further elements, right? So what I'll do is I'll add 0 with my minimum value I've observed till 0, not including 0 till 0, right, which is 3. Now I'll update my current minimum value to 0, right? Now what will happen is I'll go here, right? Now we here my pointer will come here, right? So now I encountered 3. Okay, I see an element smaller than the current element, right? I see an element smaller than the current element. Okay, now what do I have to do? I have to pop it out. So what I do is, ideally I remove this element out of my stack. Then what will I do? I've removed this out of my stack. Now the top of the element is 5 and my current element is 3. Okay, 5 is greater than 3. Perfect. Now I found a j which is greater than k. Now I need to see if the minimum element that I've encountered till now, which is 3, right? Minimum element that I've encountered till now is 3. That is, till before here, the minimum element that I've encountered is 3, right? You can ask me, can it be 0? No, because this is my k, so this will be my j, right? Because that is the element. So what do I have to do? I have to find an element, minimum element that I've encountered till 5, right? Because of this condition, j is greater than I and k is greater than j. Because of this condition, I found a k. Now I found a j, right? So I'm trying to find a maximum element before this, right? I found 5. Now what do I have to do? I have to find an element before 5 which is less than k, right? Before 5 which is less than k. Makes sense, right? Because since this is my j, I would need to pass this condition, I would need an element before I, which is less than k, right? So since this is my j, I need to find an element before 5, not including 5, before 5. That is what I've stored over here, right? So what is 3? 3 is the minimum element till 5, right? Perfect. Now I found j to be greater than k. Perfect. Now I'll check I, right? That is the minimum element, that is 3, right? So is 3 greater than 3? No, it's not, right? 3 is not greater than 3. Now what I'll do is I'll put in 3. What is my minimum element that I've encountered till now? It is 0, right? That is, until 3, what is the minimum element I've encountered is 0. Perfect. Now I'll push my k. Okay, now I'll come over here. Now what's gonna happen? It's gonna check, okay, 3 is there. Okay, now I have to evict this out of the stack. I'll pop it out. Now 5. Okay, I see a 5. Okay, perfect.
So 5 is greater than 4. Perfect. Now what I'll do is, okay, I'll set this as my k. This can be our uh, this can be our j. So this will be j, and then I have to find a minimum element until 5, right? Until 5. Perfect. What is the minimum element until 5? It is 3, right? The minimum element until 5 is 3. Okay, I'm checking if 4, that is k value, is greater than I. This is I. I'm checking if 4 is greater than 3. Yes, it's greater than 3. Perfect. So I found the 1 3 2 pair, right? It is 3, which is I, and which is 5, which is greater than 3, and also greater than 4. This is my k, this is my j, this is my I. Perfect. This is our 3 to 1 pair, where your j value is greater than your I value and also your k value, right? Perfect. So since I found my answer, what I'll do is I'll simply return perfect, right? This is our approach, and let's code it up and see, and let's see how it works. Okay, right? So I'll initially have a stack of integer, and I'll call it my stack equals to new stack. Perfect. So I declared my stack now, right? I need a pair, so I'll create a class pair. This will have just int key, which is the maximum element, int value, which is nothing but the minimum element, right? So here I'll create a new constructor. I'll call it int key, int value, and then this third key equals to key, and this third value equals to 1, right? Now what I'll do is I need to get the key, right? So this will return my int get key, right? Which will return this dot key. This refers to the object that I'm accessing, that I want the key for, right? Similarly, I need the value public int get value. So here I would have I need to return this. Return. So I'll return this dot value. Okay. You can also have a integer of size 2, and then you can have stack of type. Sorry, you can have an array of size 2, and then you can have a stack of something like this, right? Of size 2. That's okay. I'm using a pair, so I'll declare it as a pair. Perfect. Now what I'll do is I'll go through my array, right? For okay, now I need to insert my element to the stack, right? Okay, what I'll do initially is I'll just say I'll create a new pair, that is my stack dot push. Minimum value will be, so I'll create a new pair. Minimum value will be nums of 0, right? And my maximum value will be also my maximum value will be nums of 0. My minimum value also will be nums of 0, right? Perfect. So I pushed. Now what I'll do is I'll iterate through the array from the first element. For int I equals to 1, I less than nums dot length, and then I plus plus. Perfect. So I'm going from the first element. Okay. Now what I'm checking is I'm checking if right. So what I'm checking is I'm checking if this stack, like the top element of the stack, if it's greater than the current element, right? If it's greater than the current element, I'm checking that, right? 4 okay, I need to have another integer called as int current min will be equal to nums of 0, right? Now I'm going from the first element, right? From the first element to the length of the array. what I'm going to do is I'm going to check if my stack dot peak right, it's a pad, right? So I need to have something like this. My stack dot peak dot get key, right? If it's greater than, I'll store the value int val equals to nums of I, right? If it's greater than I'll do one thing. I'll have a first. I will pop out all the elements. So what I'm saying is, while my stack dot size is not equal to 0, and right, my stack dot peak dot get value, get key, right? Get key is lesser than, right? Is lesser than or equal to my value, right? So with this, what I'm doing is I'm just saying my stack dot pop. I'm removing my stack when my stack has values which are lesser than the current value, because the first element, that is the max value of the stack, will always contain the max value until that particular current element, right? Perfect. Now if my stack dot size, right, is not equal to 0, and right, and if my stack dot size is not equal to 0, which means that there exists an element which is greater than my current element, right? And my stack dot peak, okay, dot get value, right, if it's greater than my current value, which means that I found my answer, return true. Perfect, right? I found my answer. Okay, let me explain this again. What I'm trying to do is, if my stack dot size is not empty, like ideally if I'm not popped out all the elements, right, if I'm not popped out all the elements, in that case my stack dot size will not be empty, right? If it's not empty, it means that there is an element which is greater than my value. Okay, perfect. If there exists an element which is greater than my value, next what do I have to find? I found my k, I found my j, I have to find my I, right? So your I, right, that is my stack dot peak dot get value, should ideally be less than value, not greater than. It should be less than your value. That is your I, right? Your I has to be less than k, right? If it's that is the case, I'm going to return true, right? Else what I'm going to do is I'll just say my stack dot push new pair of value, comma, current min, right, which is nothing but 3, which is nothing but the minimum element. In the example we saw, it was 3, right? And also also I need to assign my current minimum, right? Current min will be math dot minimum of current minimum, comma, my value, right? So I pushed it into my stack. I pushed my minimum element to the stack. Now what will I do? I'll have to move on to the next element, right? So if it is not returned true here, ideally it will return false, right? Because I have not found my element. Perfect. Yeah, let's try to run it and let's see how it runs. Okay. Sorry. Perfect. Let's try to submit it. Perfect. Let's analyze the time complexity. Time complexity would be O of n,
because you're just iterating through the elements, total number of elements in nums, right? And you're either popping out at max n elements, and that is the reason you have a while loop. You'll be at max adding n elements, and you'll be popping n elements, so that'll be 2n, and ideally it would be n, right? And what is my space complexity? Since I'm using a stack which is storing my elements from nums, it'll be O of n, right? Perfect. I hope you understood the solution. I would suggest you to code it on your own and then explain it to yourself so that you get a better understanding. Right? Thank you so much.